Okay, so welcome to our YouTube channel, and this is Python for Engineering. So we are live at the moment, and what I want to teach is Python functions. So far we've learned about variables, variable name, typecasting, converting one data type to the other. What are the different data types? What are strings, and how do you work with strings, such as methods of strings and for loops, while loop, if statements, if else, and all those stuff. Now today we're going to learn one important part of programming which we call functions. Okay. So all along, some of these common functions you've been using is a moment here. I'm coming. Okay, so all along what we've been using is print. Okay, we use print. We've used end, no, exit. I don't think we've used exit before, but I'll talk about it. We've used len function. We've used sum at some point in time. We've used random, okay, at some point in time, and so on and so forth. So let me quickly teach you one new function you want to use. Enumerate. Okay. So this enumerate function generates a series of data giving uh, uh, an iterative data. Okay. For example, maybe you want to say, for example, let's say you have a list. Let's say you have some names, and the names, we have a list of names. We have Kojo, then we have Jojo, then we have, let's say, Mojo, then we have Akwesi, or something like this. Okay, so these are four names we have. So sometimes you may want to do this. Count is equal to 0. Then you can say for I in names, okay, print what? Let's say count plus 1, add 1 to count, then you print what? Count, comma, I, okay? Or instead of saying this is names, then say name here. So for name in names, print count the name, okay? So instead of writing something like this, when we run it, we get we are generating 1, 2, 3, 4 for these names. Okay, so that's what basically is doing. So we add 1 to count, we print 1 and the name, then another 1 to the 1, making 2 and the name. So instead of doing this, we can use what? Enumerate. Okay, so let me comment this one out and let me use enumerate on the other hand. Okay, so here, instead of initiating a counter, all what you have to do is say, for, let's say, name in enumerate. So in enumeration, we have to put in the I trouble, which is the names, then the starting point. So we want to start from 1. Okay, sometimes you might input the step. Okay, no, the start, let me see. Okay, so semicolon, then you say print name. Okay, so this enumerate will by default generate numbers attached to the name. So this one will come in pair. So you could see a tuple, int string, int string. So when we run this, we get what? 1 for Kojo, 2 for Jojo, and 3, and so on and so forth. When you put in an asterisk, you mean it should clean the data and remove these excess quotation marks and things from it. So we get the same output as we're getting from here. So with the enumerate, it generates a series of numbers and attach it to them. Let me see if this one will work. I'm coming. But I'm suspecting an error. Yes, I'm expecting an error. Takes only 2 arguments. Exactly. Yes, this is what I need. So keep this in mind. It says what? Type error. Enumerate takes at most 2 arguments. 3 were given. I gave it 3 commands, names 1 and 2. There are 3 arguments, but it says it takes in at most 2 of them. Okay, so that is enumerate for you. Okay, now that we've learned about enumerate, let us see the general structure of functions, such as the print function, the exit function, and other stuff like that. Okay, so one thing you have to know about functions are, one, they have a name. Okay, so for example is the print function. The name is print. Okay, it sounds weird, but that is it. Input function, the name is input. The sum function, the name is sum. Random is random. Exit is exit, whatever it is. So realize that these functions have a name, and before you can use the print function, you have to first type print. You can't just say this. You can't just write this and say hello, and when you run this, you expect to see a result. Nothing happens. So if I want to print this, I say print. Okay, so you have to mention the name of the function to activate the function. Okay, so I think that is common sense. Now the next thing is we have to show is that functions taking arguments. So 2, they also have what? Arguments and parameters, but we'll talk more about parameters later. So argument example, it could be any data type, it could be any data structure, it could be anything. So for example, if you take the sum function, okay, sum, whatever we put in here is what we call the argument. Okay, so if I put in 1 2 3 4 5, that is my argument. The argument I've given sum is this list. Okay, the argument I gave the print function is hello. Okay, so arguments are the data, okay, we put inside a function and we put it into the bracket. So by default, the function is just like function name. So let me say, when you are calling a function, you mention the name of the function. So you say function name underscore name. Then you put in what? A bracket. Then you put in your argument or arguments. Okay. So we call the name, brackets, and our argument. And if you realize we've been doing that for all these ones, we did it for enumerate, for print, for exit, for input. Let me add input. It's one of the common ones you use. Input for len. Okay, I've used len already. Maybe max function, sum function, no, mini, and so on and so forth. Okay, so you call the function and you put in an argument. Now remember that some functions have, so let me say A, some functions take no argument. They take no argument. For example, exit. Okay, you don't need to put in anything here. When you put in something here, you get it wrong. Exit, Okay, so nothing happened, just says hello. So it exited. Let me see. So it needs a code. Okay, so exit code 1, but exit literally takes in no function, no argument. So once I run this, exit means stop or close the. Let me open the Python itself, Python interpreter. Okay, so let's open Python interpreter. So here we are in the Python interpreter. So I can say print hello. Okay. Oh, I said print hell. So whatever it is, once I say exit, it will shut down the program. Okay. So that's what the exit does. It doesn't take in any argument. Okay. So another information you need to know is we have takes no argument. Then this one, there are some functions that takes only one argument. Okay. For example, the sum function. Okay. The sum function takes in only one. You can't say sum. If you say sum without an input, you are going to get an error. Oh, because of this exit, it won't get there. So sum, we get an error. Type error. Sum takes at least one positional argument. 0 given. So we need to put in something. So you can say sum, let's say 12, 13. No, I think some can take in more. 45, 20. Okay. So when we run this, let me try and print the answer out. Let me say ANS is equal to, yes. Then I say print ANS. Okay. So when I run this, I get 90. Okay. So it sums it up for me. Okay. So let's see if we try to put in extra data. Sum takes in an iterable comma and more of them, then start, which is an integer. Okay, so let me try and put in an extra one. Let me say 1, 2, 3, 4. I'm just trying to test it out what will happen. We get, so can only concatenate list, not int to list. Okay, so we can put in something like 3 and let's run it and see. We got 93. So the sum can add both of them. Okay, remember that without these three, we get 90. Okay, so we can add an extra one, we can add 89, we can add a 90, as many as we want. Oh, sum takes at most 2 positional arguments. So this one takes in 2 positional arguments, not 3. Okay, let me look for something that takes in 1. Okay, the len function. The len function should do the trick. So len doesn't take in 2, takes in only 1. So it's just objects. Okay. So when we put in a string hello, that is all. You can't add any other comma and say hi. No, you are going to get an error. So the len function takes exactly 1 argument. Okay. So there are some functions that take in 1 argument, some functions taking 2 arguments. So let us look at takes 2 arguments. Okay, takes 2 arguments. So for example, functions that take in 2 arguments is the sum. Okay, so we can say ANS is equal to sum into brackets, let's say 23 and 89. Okay, so it can sum the two up for us. Sorry, this one has to be an I trouble. Okay, so we get 112. Okay, so it can sum these two for us. We can add some more, so 140, 600, and so on and so forth. Yes, there's supposed to be a comma here. So you realize that this is the first argument. This list is the first argument, and this single integer is the second argument. So at most, the sum can take in only two. See, this comma tells us that there are only two of them. Okay, it can't take any other form of argument, but it can also take one. So this one means that at most two arguments. Okay, so can take at most two arguments. Okay, so let us look at other uh, functions that do take in infinite arguments. Okay, let me say more than one argument. Takes in one or more arguments. Okay, so for example, answer. Let's take the print function is a common one. We can just say hello. Okay, we can just say hello, and we run it, and we get none. Oh, sorry, you can't assign a print to a variable, you get a none. Okay, so when we run this, we get hello. So you realize that we can also put a comma and say hi, and put another comma and say good, and put another comma and say great. Okay, so we can go on and on and on and on, and we get all of them. So this one takes an infinite number of arguments. Okay, so now that you know the structure, and anytime you use a function, it what returns an output. So the third thing you need to know is 3 functions return outputs or return something. Okay, now some of the functions, they might return none. So usually functions that do not want to return any output, they return none. Okay, for example, what can I do to return a none? It doesn't require okay, so let's say yes, it returns none. For example, the print function we did, like answer is equal to print. Okay, this one is going to return a none for us. So when I'm to print this ans, the function returns no output. Even you can see it here, none. Prints, it only prints out the value. It doesn't return an output. Okay, it displays the value for you. Its work is to display the value for you. Once it displays the value for you, it doesn't return an output. This one will make sense later. Okay, so let me run this, and I have none. So you realize that nothing is working. It doesn't perform any calculation and return the value. But if I have something like a len, so a len, let's say the length of, let's say hello, which is supposed to be 5. So when we run this, hello calculates and returns the length of the character, and now we can print it out. So a function like print returns what? None output. Some of them returns a single output. Okay, one output. Some of them returns a multiple outputs. Okay, multiple outputs. Okay, so multiple outputs usually they come as a tuple. Okay, they come in brackets. For example, the enumerate. Okay, for example, when we did enumerate into brackets, let me put in something. What did I use before? Names. Okay, names. Then I say start from 1. Realize that when we print this one out, it's we get this, but let me show you the results. So this is a multiple output. So every single name in names gets a number attached to them, and it comes in pairs and comes multiple times, depending on the number of times there are names in there. So you can generate one output, no output, or simple. Okay, so it's not always that your function would get an output. And secondly, it's not always that your function will take in an argument. You can have a function with no argument, one argument, at most two arguments, or one or more arguments. Okay, and always it should have a name. Okay, now that I've successfully explained these concepts, let us go into creating our own functions. So let's see, is there any questions in the comments? Oh, so Clinton is saying that the plus equal to 1 means increase that variable. Okay, so so you can say count is equal to what? Count plus 1. So the old count variable is equal to what? Plus 1 will be assigned to the count variable. So instead of having this, we would rather say what? Count plus equal to 1. Okay, so it's the same thing. So both of them are the same. It's just a smarter way of writing it. Okay, that's all. So when we talk about the Python functions, so in order to create a function, follow this syntax. Syntax for creating a Python function. So rule number 1, you say def, then you state the function name of your function, then you list your argument or arguments. Let me just make it plural. I'm assuming you end it with a semicolon. You come to the next line and indent. Okay, then you put your code here, action codes here. Okay, then when you are done with your action code, you say return what? Return your result or output. Return the output. Okay, so whatever output you get, you return it here. Now if you don't put any return, so if there is no return, then your function will return none. Okay, so I talked about none output. Okay, so let me use this syntax to create a simple function. Okay, so first says state the name def. So I'll do that. So here we are what? Creating a function. So I want to create a function that can calculate the area of a surface. Okay, so I would say def, let me call the function name area, or let me say calc area, into bracket. Then I provide my list of arguments. So what will be the argument? Argument means so in here you provide your list of, sorry, it's parameters. Okay, now I'll explain the difference between parameters and arguments. Okay, so in here, in order to calculate the area, what do we need? Let me come up here and say formula. Okay, so to calculate the area, we need what? To find the length, then we multiply it by what? The width. Okay, so we need to ask the user for the length, let's say L, then we need to ask the user for the width, W, okay, semicolon. So in here, you get to realize that we have two parameters, okay. So parameters are the variables we put inside the bracket, meaning that the user is going to provide that data later. The user in future will provide us with those numbers, but for now we don't know what the user is giving us. So we put in these variable names to hold that place. And these variable names are what we call parameters. Now, if in future the user puts in 2 and 3, then the 2 and 3 becomes argument. So for example, if I'm solving an area and I say area is equal to, now the length is let's say 20 times the width is let's say 4, this 20 and 4 are the arguments. So 20 is the argument of the length, 4 is the argument of width. The length and the width are the parameters. So the parameters are length times width. The parameters for calculating area is multiplying the length times the width. Now, in an actual calculation, your argument for a particular instance of calculating the area, you say what? A certain number times a certain number, such as 20 times 4. So the 20 times 4 is our what? These are what? Arguments, and these are the parameters. Okay, so if you have a question on that, let me see. In my last print function, I put an asterisk, okay? So I put an asterisk, um, I put an asterisk to unpack the variable and remove excess bracket, or like remove the commas and brackets, okay. Please increase the likes, okay, increase the likes. So at least everybody should like one. I'll get like 7 likes for now. So from here we know that these are arguments and these are parameters, okay. So we put in def calc area, the length is L and the width is W. So once the user provides us L and W, then we'd say that maybe our answer is going to be what? L times W. Then we return what? We return answer. So this is a simple function. So this function, what it does is it calculates what? The function name is here. So if you take a look, def function name, list of parameters, followed by semicolon. So def, our function name is what? Calculate area, calc area, into bracket LW, then semicolon. Then our action code is here. So in this case, our action code, we are multiplying the length times the width to get our answer. And when we are done, we return what? Our output. And our output we want to know is what? The area. So here, if we run this function, nothing will happen. Nothing happens, because if you create a function, it doesn't work. Remember, I said for functions, you need to what? Call their name. So if I want to use this function, then I'll say calling my function for use. Okay. So here I can say that maybe I can put a new calculation. Let's say result. Okay, I have a variable called result. When I call my function such as calc, the same way you call len, like len and blah blah blah, you can say calc area. Then I put in my length value. So my length value, I can say 20. So this 20 is my argument. Then the width is 4. So 20 and 4 are my arguments. So in this case, my function takes in only 2 arguments. Okay. Because when I was creating the function, I only provided 2 parameters. So my function takes in only 2 arguments, and that is it. So once I'm done, when I print results, this function would multiply 20 times 4, giving us what? 80. And to assign the 80 and to return the 80 to this result. So at the end of the day, this will become is equal to 80. Result will be equal to what? 80. This is what will happen. To perform the calculation in here, then return the output. If we don't return the output, they will get stuck inside the function forever. Return means that bring them out. Okay, so print result. Let us see what happens. So 80 comes out. Okay, so we've learned how to create a simple function and how to call it. Now let us take a look at no, imagine we didn't say return anything. It will rather return none. There is nothing. It will perform the calculation but never returns the answer to us. So when we print out, we get what? None. So this one will return a none type of data. Sometimes you may want to create a function that you don't need to return anything. Okay, you may want to create a function you don't need to return anything. Like yesterday, I did something. So let's say we want to create a function that clears the console. Okay, so let me come here. Let me come here instead. So let me say def maybe CL maybe fresh. Let me call it fresh page. Okay, so I don't take in any arguments, any inputs. I would say CLR is equal to clear. That's for if operating system dot name is equal to or is in this list nt or doc, or is it, am I correct? I don't know. We say what? CLR is equal to what? CLS. CLR is rather equal to CLS. Then we say operating system dot system into bracket CLR. Okay. So let me import OS. Okay. So this clears the console. Okay. It will delete everything from the screen. So let me just call the name fresh page. So here I'm not returning anything. It's just to clear the, once I call it name, it just clears the console. I don't need to take in any input. I don't need to return any output. So when I run this, realize that the console comes, but it clears it off. This none is coming from this side. Okay. So if I'm to do this, so all the things above here, you won't see them. Now, if I'm to take off this refresh thing from here, delete this one. When I run it, you see these things. So when I say refresh page or fresh page, it clears these things away. Okay, so when I'm to run it again, it clears it off and starts from a fresh page. Okay, it has terminated the code. That's why you see this. Okay, so that is that's a typical function I use a lot, especially when I'm dealing with console-based applications. So this one doesn't need an input, so it takes 0 arguments. It doesn't give an output. So in case I do this, let me say result. Okay, in case I do something like this and I try printing it out, I'll get a none. It clears the screen and I get a none because it doesn't return any output. I've made it not to return any output. So when you assign it to it, you get a none. Okay, so take note of that. Now let us take a look at okay, so here we say what? Return answer. Okay, so this is a simple function. Okay, by now you should be able to write a simple function. Now let us create more functions here. So let me create a function that would calculate volume. Okay, so to calculate volume, now let us write a formula. So volume, let's say volume is what? Length times width times height. Okay, and that is volume. So if I want to create a function for that, I'll say def maybe calc volume. That's how I want to name it. Calc vol to bracket length times width times height. Okay. Now, given this, I can say that now my answer is going to be what? L asterisk breadth width times height. Now say return answer. Okay. Okay, so I can return my answer. So here, when I change this one to calc vol, now this one becomes my length, this one becomes my width. But remember, the volume function takes in 3 arguments. Okay, so we need to provide one more. So that would, let's say, 4.5. Okay, so when we provide this and we run it, we get what? 360.0. So it calculates the volume for us. Okay, it's by default calculates the volume for us. Now imagine, let's say you want to create a function. Sometimes you want to set some default parameters. For example, let's say decimal place. Okay, I can say for decimal place, the user, for now, the user has to provide a number of decimal places. Okay, so in order to use this, I have to say maybe I want it to 0 decimal place. Okay, now I have to use this dp my calculation. So once I'm done with this calculation, what I'll do is, let me say, final answer is going to be what? Round this answer here, comma, to decimal place. Okay, so you should round this answer to a decimal place. Okay, so the computer can do this for us. So in case I provide, let's say, 20.789, then 4.01, then 4.5. I'm saying round it to what? A 0 decimal place, meaning the nearest whole number. When I run this, I get my results in the nearest weight. Oh, I'm not returning final answer, I was rather returning answer. So let's say final answer. Okay, let's run it again. So we get what? 375. So it's rounded to the nearest whole number. So I can change this decimal place to 1 decimal place and rounds it to what? The nearest 1 decimal place from me. 2 decimal place rounds it to the nearest 2 decimal place. I can say 5 decimal places rounds it to the nearest, because there are only 4. There are only 4 digits. So there are only 4 decimal places. So when you say 6 decimal place, you keep on getting your decimal places. Okay. So now sometimes users may not be bothered about decimal places. Everybody knows that by default we round to 3 decimal places. Okay, most of the time. So we can say, or let me start with this concept first. So sometimes you might want to make some specification. For example, when we are using a certain function like the sum function, for example, when we say sum, we can put in a number here as 1234. Okay, we can only provide, if we provide one input, one argument, it still works. We can go ahead and provide a second argument, that is 34, and it will still work because the computer assumes a default value. Okay, so when you take a look, vev sum and I trouble, then start and default, the start value for the default is what? 0. So if you don't provide this 34, the computer assumes it's a 0 and still performs the calculation with a 0. When you add 0 to any number, you still get the same number. So let us learn something about default values in a function. So here we have the length, the width, the height, but we want the user to provide a certain number, okay, as default, like to provide a number. But first and foremost, what kind of number do we want to accept from the user? So you can put semicolon and say int. So it means that if the user provides float, we don't want it. We can't round to a float. we are expecting 0, 1, 2, 3, and so on and so forth. So if the user puts in something like 3.3, that will be what? Value error. We've told our function to only accept what? Integers, not floats. So type error, okay, float objects cannot be interpreted as what? Integer. So it says that the DP that we gave, we want it what? As what? An integer, not what? A float. So the user is forced to put here as a what? Okay, good. So we can, instead of saying integers, we can also specify that the user should put in 3 decimal places. No, we can say DP is equal to 3, meaning that if the user doesn't provide the number of decimal places, the computer should assume 3. So for example, if the user doesn't provide it, the computer will assume a 3 decimal place. Okay, so this is the length, this is the width, and this is the height. And we didn't provide a decimal place, so the computer uses the 3. But if we do provide it, let's say 0, it overrides these 3 we've given as a default value and round it off to the nearest what? Whole number. Oh wait, this is first, second, and third. Oh no, 4.789. Okay, so when I run it, I get to the nearest what? Whole number. Okay, but if I don't provide a decimal place, it rounds it to the nearest 3 decimal places for us. Okay, so that being said, we can use default. So with the length here, we can force the user to put in a float. Both integers and this one are seen as float. The width, we can say semicolon float. The user can put in a float. But if the user doesn't provide a height, we can say that the computer should assume the height is 0. If you don't provide a height, then you're not dealing with volume. So by default, your answer should be what? 0. So if let's say I put in the calc volume, I put in width, length of 40 and width of 5, the computer should assume that the height is 0. So you are dealing with a plane, and planes don't have volume. So the answer will come out as 0. So we can set some parameters as defaults, okay, so that our users may not need to provide them in instances where they don't need it, okay. Now, a typical example of a default value in a print statement, if you can see, if you realize, we did something like this. For I in, let's say, 1, 2, 3, 4, 5, print I, let me run this. Now, when I printed I get 1, 2, 3, 4, 5, okay. Now, I realize that there are some default values such as what? End. The end of it, the end of the string is set to be what? End is equal to \n. So anytime you print a data, the next one will come to the next line. The next one goes to the next line. But I can say end is equal to a space. So by default, if I don't specify the end, the computer by default goes to the next line for me, unless I specify the end. So you see that they use the same trick here. So since I specify the end, I get 1, 2, 3, 4. But if I do not specify the end, the computer assumes that I want to go to the next line, because that's the default value. Then we have the separate, meaning if n is a long string, separate them by, or maybe if you are printing multiples of them, let's say I and another I, all these 3 I's we are printing, the computer should separate them by default, the computer separates them by space. Okay, so this is the default value. So when I run this, you see them appearing 3 times. But when we say separate, sep is equal to, let's say hyphen, so separate by a space and a double hyphen. When we run this, we get the separation like this. So these are default values inside a print function where you can manipulate. So you can say separate by this, and end, do not end with the next line, but rather end with just a space. So we are saying that when you're done printing this one, do not go to the next line, but put a space and continue with the rest. So this is what you get. Um, Ones, the twos, the threes. So these are default values. If you don't provide it by default, the computer has values, just like we did for this one with the volume function, the calculation on the volume function. Now, I think I've gone into details with that, but there's one more thing you need to know so that your programming goes to the higher level. I do not know if we are going to learn functions from tomorrow. Let me check my document. If you are going to learn functions for tomorrow, then I'll end here. So the new given our outline, okay, not this one. I think not this one. Yes, version 3. Okay. So after the examination break, we've done for loops, while loop, Python functions. Okay. So constraining your arguments and parameters, I've taught you that already. Oh, I didn't mention global variables and local variables. So let me mention global variables and local variables. Then tomorrow we still go on functions, but we see how we can import functions. The reason I'm talking about this is I think some time ago I showed you my project where I programmed this software in aerospace, and the software was like having 3 screens. I splitted a screen 3 times, something like this, something like that. Okay, I'm coming. This, then like that. So I think I splitted my screen. There was one here, there was one there. Okay, so I had something like this, and I was working between them. So how did I get data from here, codes from here to run here, and from here to run, because they are all the same project. So I'm going to teach you how to do that tomorrow. So tomorrow's lesson is going to be great. Do not miss it. Okay, so tomorrow I'll show you how to import and export functions, your own functions or other functions, and we'll see that in here. So far so good. I've taught you more than I should. But now let me talk about local. Okay, tomorrow we'll talk about local variables and global variables. Let me take you some questions, then we continue. Remind me to talk about that. Okay, please increase the likes for me. Increase the likes. Increase the likes. Okay. So any question in the comments, then I answer that one and we close. We are 4 minutes away from closing. Okay, I'm not receiving any question. So we'll end our session now. Please do well to increase our likes and we'll be grateful for that. So the session has come to an end. I would send your projects to you. It's unfortunate that yesterday's projects, HackerRank didn't allow me to upload them. Today, I would upload them, and well, thanks for the reaction. Keep the reaction coming. Okay, thanks for that. Okay, so see ya. Bye for now.